This example comes out of section 5.2, horizontal asymptotes. To have a look at horizontal asymptotes, the first example I look at is this function here, y equals x squared plus 2 over x squared plus 1. Kind of nice in that we don't have to go through the whole analysis of where it has vertical asymptotes like we did in the previous examples, because this one really doesn't. There's nowhere where the numerator or denominator equals 0. So not only does it not have x-intercepts, it has no vertical asymptotes. If we're eventually going to try to draw a graph of this thing, one point we could put in is x equals 0, and we discover that we've got a point at 0, 2. But what else this graph does, we would need to do a bit more work. Horizontal asymptotes basically describes what happens as x gets infinitely large or x gets infinitely small. In other words, what if I do the limit as x approaches infinity of this function here, x squared plus 2 over x squared plus 1. Now, if you can remember far back enough to chapter 1 when we did limits extensively, what we did was we said, well, divide everything by the greatest power of x there, and you end up with something that looks like this. And why that's useful is that you have the limit as x approaches infinity of 1 plus 2 over x squared over 1 plus 1 over x squared. Now, as x goes to infinity, this ends up becoming 1 over 1, because 2 over a huge number heads towards 0, and 1 over a huge number heads towards 0. And the truth is, this happens whether you put in infinitely large positive numbers or infinitely large negative numbers. And so what you have here is a horizontal asymptote at y equals 1. So if on my graph I put a little dotted line here at y equals 1, what's going on is that my graph approaches it infinitely as I go that way, and infinitely as I go this way. So as you put in larger and larger positive numbers or negative numbers, you'll get closer and closer to 1 without ever actually reaching it. And prove that to yourself, put in a number like 1,000,000. You've got 1,000,000 squared plus 2 over 1,000,000 squared plus 1. Well, that's going to be as close to 1 as you can imagine without actually being 1, 1.00000000 something. If you were to have tried making a table of values for this function and take a look at some actual values, if I put in 1, 1 plus 2 over 1 plus 1 ends up giving me 1.5. And that's true actually for plus or minus, because it turns out to be an even function. If I try putting in a number like 10, plus or negative 10, I get a number 1.0099 something. You can get as carried away as you want to, but put in a number like 100 and it gets even closer, 1.0001 something. Put in 1,000 and it's even closer and closer and closer. So you can see that as numbers get further and further to the right or to the left, that this graph does approach its horizontal asymptote at y equals 1. So to generalize, if you have a function, if you find the limit as x goes to infinity of your function, and the answer is L, whatever that limit might be, or if you do the limit as x goes to negative infinity, and the answer is something, and we'll call it L just so that we have an answer for L. What you have is a horizontal asymptote at y equals L.